So we've got this soil profile here. Imagine there's a facility here. There's been some kind of release, and through gravity, this product is percolated down to the water table, and that water table raises and lowers seasonally, making this smear zone. It sort of smears those contaminants within the vadose zone. And early on in a spill, a lot of the depletion is dominated by methanogenic degradation, or basically degradation that produces methane, the CH4. It also produces CH2 or CO2. So that's where there's little or no oxygen. Where there is oxygen, you produce carbon dioxide. And so if you're able to measure these are the byproducts of the hydrocarbon depletion. You can infer depletion rates from that based on what you know about the chemistry. So this is where you get, if you were to put sensors in here, you could get two estimates of depletion. You can measure the hydrocarbons themselves. You can also measure their byproducts. And then because you've got natural soil respiration, you want to subtract any other CO2. Even if this site wasn't here, you would have carbon dioxide and methane. You'd want to subtract that background to get a more robust signal. And so if you're not, traditional approaches would typically have a sensor on the surface and they would just measure carbon dioxide. But if you're not measuring methane, which dominates processes early on, and also it might not be a valid assumption that all that methane is oxidized to CO2, you're actually missing out on a lot of the depletion. So it's really good to measure methane, and also because it kind of ebbs and flows in its release, you'd want to measure it through time as well.